In this video, I'll be solving AS Math paper 1-2 from November 2023. In the first question, we have the expansion 3 plus 2ax power 5. And the coefficient for x cubed is 6 times the coefficient of x squared in the expansion 2 plus ax power 6. From the first expansion, we'll find the term 5c3 for x cubed. We have 3 squared and 2ax power 3. This gives us 720 a cubed x cubed For the second expansion, we need the coefficient for x squared. So I'll need the term 6c2. Two power 4 and ax power 2. So this gives me 240 a squared x squared. Now, equating the coefficients, the coefficient for x cubed is 6 times the coefficient of x squared in the other expansion. So 720 a cubed is equal to 6 times 240 a squared. A is equal to 6 into 240 divided by 720. This gives me the value for A is equal to 3. A is equal to 2. We need to find the exact solution in question number 2 for the given equation. Tan inverse of 4x is equal to minus pi over 6 minus cos inverse of 1 over 2 times root 3. Tan inverse 4x is equal to minus pi over 6 minus pi over 6. Tan inverse 4x is equal to minus pi over 3. Or x is equals to tan bracket minus pi over 3. This comes out to be 4x is equal to minus root 3. So x is equal to minus root 3 over 4. In question 3, we're given the dy by dx equation, half x plus 72 upon x power 4 and the curve passes through the point P, which is 2, 8. We need to find the equation of the normal at P. So when we plug in 2 in the dy by dx equation, we'll get the gradient for tangent. This would be so the gradient of the tangent is 5.5. Now the gradient for normal would be the negative reciprocal of this, which would be minus 1 over 5.5. We're given the coordinate and we have the gradient now. We just need to construct the equation. So y minus 8 is equal to minus 1 upon 5.5 multiplied by x minus 2. Now let's just make y the subject over here. I have 5.5y is equal to minus x plus 46. I can simplify this to 11y is equal to minus half x plus 23. So that would be multiplied by 2. So this would be minus 2x plus 92. So the equation can be given as 11 plus 2x is equal to 92 as well. Now in part B, we need to find the equation of the curve, which we can find by integration. Integrating dy by dx, which is half x plus 72 x power minus 4. We'll add 1 to the power and divide by the new power. X square upon 2 plus 72 x power minus 3 divided by minus 3 and a plus c. Y comes out to be x squared upon 4 minus 24 upon x cubed plus c. Now we can find the value of c by using the given coordinates of 2, 8. 8 is equal to 2 squared upon 2 minus 24 upon 2 cubed plus c. 8 is equal to 2 minus 3 plus c. C is equal to it should be 1 upon 4. This would be 1. C comes out to be 10. So the equation would be x squared upon 4 minus 24 upon x cubed plus 10. Now in question 4, we're given the diagram which shows the shape of a coin. The three arcs AB, BC, and CA are parts of a circle with the centers C, A, and B respectively. C is the center for the arc AB. B is the center for the arc AC. And A is the center for the arc BC. We need to find the perimeter of the coin. ABC is an equilateral triangle. So theta would be pi over 3. And the radius is 2. So we have the arc length is r theta, which is 2 pi over 3 multiplied by 3 because we have 3 arcs over here. So the perimeter is 2 pi in this case. Now we need to find the area of the face ABC of the coin. So let's break down the shape. We have this segment, which is the sector minus the triangle. We have another segment, which is the sector minus triangle. And we can just take the remaining shape as the whole sector. Basically, area of sector minus area of triangle gives us the segment, and we'll multiply this by 2 plus area of sector for the third region. So I'll have half r squared theta for the sector, half times 2 square times theta, which is pi over 3 minus half times 2 sine pi over 3, and the whole bracket would be multiplied by 2 plus area of the sector, which is half r squared theta, which is half into 2 square into pi over 3. Now this 2 outside the whole bracket gets multiplied with both the halves inside the bracket. This 2 gets multiplied by this half as well as this half. So inside the bracket, I'm left with 4 pi over 3 minus 4 sine pi over 3 plus 2 pi over 3, giving me 2 pi minus 4 sine pi over 3. The answer would be 2 pi minus 2 root 3. And the question is asking us for the answer in terms of pi and our root 3. In question 5, we have the first, second, and third terms for geometric progression as sine theta, cos theta, and 2 minus sine theta. And theta is in radians and is in acute angles. We need to find the value of theta over here. Let's find the ratio R. Cos theta over sin theta. Second term upon the first term would be equal to third term upon the second term. We can cross multiply this. We get cos square theta is equal to sin theta times 2 minus sin theta. Square theta is equal to 2 sin theta minus sin square theta. When I bring this minus sin square to the left hand side, I'll get sin square plus cos square, which would be equal to 1. 1 is equal to 2 sin theta. Sin theta is equal to 1 over 2. Theta would be pi over 6. Now, using this value of theta, we need to find the sum of the first 10 terms of the progression, giving the answer in terms of b over root c minus 1. The sum formula is a times 1 minus r power n divided by 1 minus r. A would be sine pi over 6, which is equal to half, and the ratio would be cos theta upon sin theta, which is equal to root 3. Now we'll plug these values in the formula for the sum. S10 is equal to 0.5 times 1 minus root 3 power 10 upon 1 minus root 3. This simplifies to 121 upon 2 multiplied by root 3 plus 1. Since we need this numerator as a whole number, integer, we'll multiply the numerator and denominator with root 3 minus 1, root 3 minus 1. This becomes 3 minus 1 using the identity a squared minus a plus b multiplied by a minus b, which is a squared minus b squared. 2 multiplied by root 3 minus 1. So this 2 and this 3 minus 1 cancel out each other. So S10 is equal to 121 upon root 3 minus 1. In question 6, we have the equation y is equal to x squared minus 8x plus 5. We need to find the coordinates of the minimum point of the curve. We can differentiate this. We get dy by dx as 2x minus 8. We'll equate it to 0 since it's gradient is 0 at the stationary point. X comes out to be 4. We'll plug that back into the equation for y to find the y coordinate. Y is equal to minus 11. The turning point or the minimum point would be 4 and minus 11. The curve is stretched by a factor of 2 parallel to the y-axis and then translated by 4 and 1. We need to find the coordinates of the minimum point of the transformed curve. We have the coordinate 4 and minus 11. There's a translation of 4 in the x-axis, in the x direction. So this becomes 8 and minus 11. And then another translation of 1. There's also a stretch of the factor 2 in the y-axis. We'll multiply this by 2. And then we'll translate the y coordinate by 1 as well. So the final coordinate would be 8 and minus 21. In part C, we need to find the equation of the transformed curve and give it in the required format. We have x squared minus 8x plus 5. We'll apply the transformation in the x direction first. So since there is a translation of positive 4 in the x direction, we'll subtract 4 from the x brackets. We get the equation as x squared minus 16x plus 53. And then we'll multiply this by 2 for a stretch of scale factor 2 in the y direction. So this becomes 2x squared minus 32x plus 106. And then we'll translate in the y direction by 1 unit. This would be 2x squared minus 32x plus 107. This would be the final answer for the equation. In question 7a, we need to prove the given identity. So we'll multiply 2x with the 3 terms in the second bracket. This gives us 8x cubed plus 4x squared minus 2x. Now we'll multiply minus 1 with the next three terms. Minus 4x squared minus 2x plus 1. So 8x cubed. The plus and minus 4x squares get cancelled out. We have minus 4x and a plus 1. Now in part B, we need to prove the identity. So tan square theta plus 1 upon tan square theta minus 1. So we could break this into sine square over cos square. And then we can take the LCM in both numerator and denominator, giving us sine square theta plus cos square theta upon cos square theta divided by sine square theta minus cos square theta upon cos square theta. Now once we've reached this step, we can cancel out the cos square in both the denominators for numerator and denominator. This simplifies to 1 over sine square theta minus cos square theta. Now in place of sine square, I can write 1 minus cos square theta. This proves the identity 1 upon 1 minus 2 cos square theta. Using the results of part A and B, we will solve this equation now. Tan square plus 1 and tan square minus 1 gives us 1 over 1 minus 2 cos square theta is equal to 4 cos theta. One is equal to 4 cos theta minus 8 cos cube theta. When we bring all the terms on this one on the same side, we get 8 cos cube theta minus 4 cos theta plus 1 is equal to 0. Now this equation format resembles the one we have in part A as well. So we can break this into these two factors. If we consider cos theta as x, we have 2x minus 1 and 4x squared plus 2x minus 1. We have 2 cos theta minus 1 and 4 cos squared theta plus 2 cos theta minus 1 is equal to 0. one of the factors would result in the solution cos theta is equal to half. The other value for cos theta are 0.31 and minus 0.81. We're given the domain 0 to 180. So cos is only positive in the first and the fourth quadrant, but since we're only dealing in the first two quadrants, we'll only have one angle for this. So since the basic angle is 60 over here, theta would only be equal to 60 in this case. For these two values, we have cos inverse of 0.3. The alpha for 0.31 would be 72, and the alpha for minus 0.81 would be 36. Now 36 would be plotted in the second and third quadrant where cos is negative. So the two values for theta we'll have over here would be 72 and 144. So the final answers for this are 60, 72, and 144. In question 8, we're given two functions, fx and gx. We need to find the inverse of f. So y is equal to x plus a whole square minus a. We'll shift a to the other side. We have y plus a is equal to x plus a whole square. Then we'll take the under root on both sides, the square root. We have a plus minus sign over here and x plus a over here. Now x is equal to a plus minus x plus a and since we have the domain as less than the turning point's x coordinate, we'll take the minus sign with this. So f inverse x would be minus a minus root x plus a. The range for fx would be greater than the turning point of the y coordinate of the turning point, which is minus a. So the range would be fx greater than equal to minus a, and the range of the function would be the domain of the inverse. So this also becomes x is greater than equal to minus a, and the range of the inverse would be the domain of the function, which is x less than equal to minus a. So f inverse x is less than or equal to minus a. We're given that a is equal to 7 upon 2. We need to solve the composite function g of x equal to 0. For g of x, I'll plug in the function fx in place of g, in place of x in the function g. So this would be 2 bracket x plus a whole square minus a minus 1. And we have the value for a as 7 over 2. 2 multiplied by x plus 7 over 2 whole square minus 2 times 7 over 2 minus 1 is equal to 0. 2 bracket x plus 7 over 2 whole square is equal to 8. X plus 7 over 2 whole square is equal to 4. X plus 7 over 2 is equal to plus minus 2. X is equal to minus 3.5 plus minus 2. X has the values minus 5.5 and minus 1.5. But since the domain for fx is less than or equal to minus a, which in this case is less than or equal to minus 7 over 2, we would reject minus 1.5, and our only answer over here would be x is equal to minus 5.5. In question 9, we're given two curves. And in the first part, we need to find the coordinates of A and B, which are the intersection points for these two curves. We'll equate 2x 1 over 2 plus 13x minus 1 over 2 is equal to 3x minus 1 over 2 plus 12. Now let's take x 1 over 2 as a variable p. So we have 2p plus 13 over p is equal to 3 over p plus 12. 2p plus 10 over p minus 12 is equal to 0. Once you bring all the terms on the same side, when I take the LCM, I get 2p squared minus 12p plus 10 is equal to 0. P squared minus 6p plus 5 is equal to 0. P is equal to 1 and minus 5. Now, x power 1 over 2 is equal to 1 and minus 5. So to find the value of x, we'll square both the sides. X is equal to 1 or 25. And subsequently, y would be equal to we'll plug these back into either of these two equations. So when we plug in 1, we'll get 15 for y, and when we plug in 25, we'll get 12 whole 3 upon 5, which is 12.6. Now in part B, we need to find the area of the shaded region. So we'll subtract the area of the lower curve, area under the lower curve, from the area under the higher curve. So we have 3x power minus 1 over 2 plus 12 as the higher curve. And from this, we'll subtract 2x power 1 over 2 plus 13x power minus 1 over 2 dx. And the limits would be the values of x we found in the previous part. The limits would be 1 and 25. We'll simplify this. We'll get 2x power 1 over 2 minus 2x power 1 over 2. And 3 minus 13 will give us minus 10x power minus 1 over 2 and plus 12 dx. Now we'll integrate the three terms over here. So we'll add 1 to the power and divide by the new power. So this simplifies to minus 4 upon 3 x power 3 over 2 minus 20 x power 1 over 2 Now we'll just plug in the limits and subtract the lower limit from the upper limit. We'll get this when we plug in the upper limit. And we'll subtract the lower limit from this. Minus 4 over 3 minus 20 plus 12. The area would be 128.3. In question 10, we're given the equation of a curve. We need to find the x-coordinates of the stationary point and determine its nature. So we'll differentiate this. We'll multiply the power and the differential of the bracket, and we'll subtract 1 from the power. And we'll equate this with 0. 20 upon 3, 4x minus 3 power 2 over 3 minus 20 upon 3 is equal to 0. 20 upon 3, 4x minus 3, 2 power 3 is equal to 20 upon 3. 4x minus 3 power 2 over 3 is equal to 1. X is equal to 3 over 4. We have a power of 2 over 3 over here, so we'll take 3 over 2 on both sides. So 4x minus 3 would give us the value plus minus 1. Or x is equal to 3 plus 1, 4, and 3 minus 1, 2. X is equal to 1.5. And the y coordinates would be, when we plug in 1, we'll get we don't need the y coordinates, so they're just asking us for the x coordinates. We'll differentiate f prime again to get the second derivative now. We'll differentiate this f prime again. So we'll multiply the power again. 20 upon 3 multiplied by 2 over 3. And the differential of the bracket. And we'll subtract 1 from the power, giving us minus 1 over 3 now, plus 0. This simplifies to 160 upon 9, 4x minus 3 to the power of minus 1 over 3. Now, when we plug in x is equal to 1 in this, our f prime 1 would be equal to 160 over 9. And since this is less than 0, greater than 0 and is positive, this would be a minimum point. And when we have x as 1 over 2, this would result in the value of minus 160 over 9, which is less than 0. So a negative value means maximum point. Now we need to state the values for which the function is increasing in part B. Dy by dx was 4x minus 3 power 2 over 3 is equal to 1. X was equal to 1 over 2 and 1. Now to have an increasing function, our f prime or the differential should be greater than 0. So when we apply this inequality, we'll get the set of values as x less than half and x greater than 1, since this would be an open range. This would be the answer for part B. In question 11, we have the coordinates of the points A, B, and C. A is 6, 4, B is P and 7, and C is 14 and 18. The line AB is perpendicular to the line BC. So let's find the gradient of AB. 7 minus 4 upon P minus 6 gives us 3 upon P minus 6. And the gradient of BC is 18 minus 7 upon 14 minus P. This gives us 11 upon 14 minus P. Now, the product of these two should be equal to minus 1. So 3 over P minus 6 multiplied by 11 over 14 minus P is equal to minus 1. 33 is equal to P minus 6 times P minus 14. When I multiply 14 minus P with minus 1, I get P minus 14. 33 is equal to P squared minus 20P plus 84. P squared minus 20P plus 51. This would factorize to P minus 3 and P minus 17. P has the coordinates 3 and 17. Now we're given that P should be less than 10. So the value would be P is equal to 3 only, and we'll reject 17. Now we know that AB is perpendicular to BC and both of them are chords of a circle. Now there's the circle property that if a diameter is forming a triangle at the circumference, the angle is always 90 degrees. And since AB and BC are perpendicular to each other, this means that angle B is a 90-degree angle, which makes AC the diameter of the circle. So the midpoint of AC would be the center of the circle. Six, 4, and 14, 18. The midpoint comes out to be 10, 11, which is the center of the circle. And the radius would be half of the length AC. AC square is equal to 14 minus 6 whole square plus 18 minus 4 whole square, which is 64 plus 196. AC square is equal to 260. Now, since we need half of this, AC is equal to root 260, and we'll divide it by 2. AC is equal to, the radius is equal to root 260 upon 2. R square is equal to 260 upon 4, which would be 65. So the circle equation comes out to be x minus 10 whole square plus y minus 11 whole square is equal to 65. In part C, we need to find the equation of the tangent to the circle at C, giving the answer in the form dx plus ey plus f is equal to 0. We have the center 10, 11. We have C over here as 14 and 18. We need the tangent equation. So we'll find the gradient of the radius over here. Gradient would be 18 minus 11 upon 14 minus 10, which is 7 upon 4. So the gradient of the tangent would be minus 4 upon 7. And we have the coordinate 14 and 18. So the equation for tangent can be constructed with y minus 18 is equal to minus 4 upon 7 multiplied by x minus 14. Y is equal to minus 4 over 7x plus 8 plus 18. This gives us y is equal to minus 4 over 7x plus 26. And this should be given in the form we'll take the LCM and multiply 7 to the other side. This gives us 7y minus 4x plus 7y is equal to minus 4x plus 182. And we'll bring all the terms on the same side. 7y plus 4x minus 182 minus 4x plus 7y minus 182 is equal to 0 would be the answer for this. And that's the end for this exam.